Hello everyone, my name is Siddharth. Today I am going to talk about one of the most exciting topic in the quantum technology, Microsoft Marijona 1 chip, and why it could completely change the future of computing. So, as classical computers are reaching their physical limit, quantum computing is becoming the next IG revolution, and Marijona 1 may be the biggest one of it. So, why technically why do we exactly need it? It's a really traditional or the big question. Why do we actually need it? But traditional computers use either 0 or 1 bit, but quantum computers use qubits, which can exist as both 0 and 1 at the same time using something called superposition. This gives quantum computers enormous parallel processing power. The problem is quantum systems are extremely fragile. Even tiny environment disturbance can destroy their qubit states. Means even a tiny bit of problem like a bit of heat wave or anything can destroy their whole calculations. This is called decoherence, and it's one of the biggest barriers in quantum computing today. What makes Marijona 1 different? Microsoft Marijona 1 is different because it uses something called topological qubits. Instead of regular fragile qubits, it relies on exotic particles called Marijona 1 fermion, predicted by physicist Ettore Marijona. These particles are unique because they are their own antiparticles. In Marijona 1, these appears as Marijona 0 mode, which stores quantum information, as a non-local way, meaning the data is spread out physically instead of being trapped in one place. So, how how exactly does Marijona 1 works? The chip built using hybrid material called antidium and aluminium shell. So this creates a special topological state where Marijona 0 modes form the both ends of the wire. Quantum information is stored between these two ends. Then computation happens through a process called braiding, where these major particles are manipulated around each other to perform the quantum gates. So, comparison between current quantum systems. Right now, companies like IBM and Google are superconducting qubits. These are advanced but highly noisy and unstable. They require hundreds or thousands of physical qubits just to create one reliable logical qubit. Marijona 1 promises much lesser error correction requirement. In simple words, IBM and Google systems are more mature today, but Microsoft's Marijona approaches could become far more scalable in the future. So, what are exactly the real world applications of this phenomenal invention, Marijona 1? The real world examples are drug discovery, cryptography, artificial intelligence optimization, advanced material science. Microsoft also plans to integrate this to Azure Quantum Cloud, making quantum computing accessible worldwide. So, what are the challenges and debates on this particular topic, or should I say this particular invention? So, let's be realistic. This technology is still experimental. Current demonstration only involve a small number of qubits. Also, scientists are still debating whether the observed signal are truly stable Marijona 0 mode or something less robust. So, while the promise is huge, the proof at scale is still pending. Conclusion. I will conclude my this topic with to conclude. Um, To conclude, the Marijona 1 represents a bold new direction in quantum computing. If Microsoft succeed, this could solve one of the biggest problems in the field, error correction, and bring us much closer to practical and large-scale quantum computers. This isn't just upgrade. It could be the foundation of the next computer era. Thank you for watching. I'll conclude it here. Thank you.